Dealing with objects. We are always dealing with items. Okay? Since young, the children or even all of us are really surrounded by toys, surrounded by items. So we look at the TV, okay, that's the TV. We look at the sofa, that's the sofa, and that's water. That's the table, that's the chair, you know, that's the car, and so on. So children are very familiar with all these words. Okay? That's when we try to use this strategy called the object-oriented writing. Okay. So why do you think this happened? Probably the idea of heart rates will come to your mind, right? Okay. Then you have to describe further. Like just now when I was doing the science writing heuristic, to describe further, that's when we will say things like, oh, the heart rate increases. Okay. So you can't just say heart rate. So we have to describe further by saying that it increases. And then probably you might think of this blood that's in the human body. Again, that's another object that's found in many of these science explanation. Next will be the idea of the oxygen. Okay, right? And finally, this idea of energy. So we also need to describe more, saying things like, okay, to release the energy faster. Okay. So once you have all these words are actually, if you look at them, they're either phrases or they're words, and most of them, in many of the children, so-called their answers, they have to use nouns. They have to use words that talk about objects, right? So that's why we try to link up all these objects. So that's why this strategy is called the object-oriented writing. How do we link this up? Will be something like, okay, my heart rate increases, okay? Heart rate increases because the blood needs to faster in the way of transporting, right? Transportation, okay? And the blood in our body that carries the oxygen, okay? And with more of this oxygen, that will help in the release of the energy faster. Okay, so that's how we try to link up the answer using objects. Okay, So this is just one example. Another example that you might experience or you might have would be things like, there's this candle, the burning of the candle, and then on top of this candle, we have a spiral that's spinning. So when you light up the candle, after some time, the spiral will start to spin. And then we tell the children, okay, can you write out the energy conversion? Or can you describe or explain the energy conversion taking place? So some of the things that come to the mind of the children will be things like, oh teacher, this candle, so what candle? The next thing is, and there's a flame there, teacher. So flame is another object. Teacher, the spiral up there. Then we'll ask the children, what is between the fire or the flame and the spiral? So it must be air, right? So that's another object. So with these four objects, that's how they will link up the energy conversion to answer that question. Okay? So here's the second strategy. We call it the object-oriented writing. Another example would be things like when in primary 3, when the children they learn about magnets. Okay? They don't just learn about magnets, but we are very specific. We say the poles of the magnet. So the poles become the objects of things like over here, the something, the blank, the rate of evaporation. Okay. I also have the two questions in the activity 3. That's where we bring in the idea of team 1, team 2. Okay, team 1 and team 2. Okay. Would you like to try the fill in the blanks for that two questions for activity 3? Okay, yeah. So for this third strategy, or this third writing strategy that we use, is how factor A could affect factor B, or how variable 1. They don't say how team 1 affects team 2. So they just say, oh teacher, the answer is the higher, oh teacher, the answer is the greater the exposed surface, full stop. Right? So they just end their answers abruptly without stating how the greater the amount of exposed surface affect the faster the rate of evaporation. Okay? It's not just for this water cycle topic, but even for this electromagnetic topic. Those of us who have seen the primary 3 textbook, you realize that how can I make the electromagnet stronger? Correct? So they need to have more coils, or they need to increase the number of batteries. Right? That's when we can also employ or use this team 1 and team 2 strategy with the children. Okay? Right up to primary 6 level, where they have to discuss about the characteristics of the environment, where they discuss how organism A or how population A can affect population B. Let's say I have too many lions in Africa. What will happen to the population of zebras? Right? So that's when we get the children to talk about how team 1 will affect team 2. Okay? And the last one, probably most of us, for physical science, we talk about, we teach the children about friction, right? Friction. So the rougher the surface, any volunteer? The rougher the surface? Wow, you all can go. Okay, thank you. Yeah. Can we clap for her? Because she shared the answer with us. that's how we can employ this Team 1 and Team 2 strategy, right? Okay. At the same time, I hope you also realize that when we use the Team 1 and Team 2 strategy, we don't just say Team 1 and Team 2. We get the children to describe. Right? We get the children to describe. That's when the children also need to use descriptive words, like the greater the amount of exposed surface area. Okay? The children need to describe. And this Team 1 and Team 2 answer can also be an explanation answer. Right? Okay? Yes. Let's go on to the last one. Ready? Okay. Yeah. So here we have activity. Let's take a short one, or for me to, or maybe I'll read it out for you. Okay. The last strategy that we want to introduce or to share with you is this aim, variable, and result. We call it the AVR strategy. Okay. And here it goes. Okay. Lucy wanted to find out if water affects the growth of mold. She placed 2 slices of bread into 2 sealed bags. Then she sprayed a little water onto one bread before sealing up the 2 bags. She then placed the bags on the table, right? So I think this one is quite straightforward. Any volunteer would like to share with us? Can you read for me? Can you read to the audience? What is the aim of this Lucy's investigation? Anyone? Shh. Oh, okay. Okay. Anybody? I think this one should be quite straightforward. Yes? No, I would like you to tell me what is the aim of Lucy's investigation. Yes?
Find the mold.
Sorry?
Find the mold.
What is her aim?
Find out the mold.
Sorry?
Find out if water affects the growth.
So we can highlight this part of the statement, right? Lucy wanted to find out. Okay, so that is the aim, right? She wanted to find out if water affects the growth of mold, right?
Yeah.
Correct?
Yes.
So that would be something for her aim, for an investigator. That's my aim. So if she wants to do this investigation, then she needs to have control some variables. Okay? Right? That's when we reason out with the children. Okay? One of the bread, you should add some water, and the other bread, you don't add any water. Correct? Okay? Then the rest of the conditions should be the same. Try to keep it the same. As much as possible, try to keep the same. Okay? And then later we also need to check the result. Right? And of course the result will not happen immediately, it will take some time. Okay? That's when we carry out this activity, and then we take photographs. We take photographs of the bread, right? Okay. So 4 days later, so what do you notice from the photographs? Anybody? What do you notice from the photograph? Yes? Sorry?